Yeah, so hello everybody. So I'm going to be talking about PHP's type system. So a bit about me. So like I said, my name is Peter Banyard. I studied pure mathematics, so I didn't do computer science. I work part-time for the PHP on PHP Core, funded by the PHP Foundation. So if any of you are already funding it or want to fund, thank you. And another stuff about me, I care a lot about semantics and about the type system, and I like anime. All of these points on these slides are relevant for the talk, trust me. So this is what we're going to talk today, so what PHP's type system is, and type systems in general, subtyping and Liskov substitution principle, and all the joys where PHP does type coercions. So what is a type system? So a type system is a logical system comprising a set of rules that assign a property called a type to every term. So a term in most programming languages is going to be like a class property, a variable, a function, parameters of a function, and these sorts of things. And what the type system dictates is the operations you can perform on a specific term. So in this case, what you can do on a variable if it's of a specific type. So PHP's type system is a bit complicated and has various elements. So it's split into like different categories. So we have like things we call atomic types, which are a single unit of a type, which can be primitive types, user-defined types, value types, or the callable type, which is its own glorious mess. Composite types are just basically composing them together, and then we also have like a notion of type aliases in PHP. So the primitive types are the following. So the universal type is, so it's mixed in PHP. We also name it the top type, i.e. every other type is a subtype of mixed. So everything is mixed. So if you pass something, it will always pass a type check of mixed. We have this weird resource type that exists in PHP, which is just a blob of memory. Streams, for example, are resources, and you can't type them. I have put on the right-hand side the PHP type declaration, if you can actually declare something to be of a specific type. Resource does not, for the only reason to allow us to convert resources to objects, like we did with curl in 8.1, if I'm correct. So we also have the object type, which is just object. Hash tables, our glorious arrays, which do everything and nothing. PHP has 4 scalar types, because for some reason we consider a string a scalar, but that's just our own semantics. But so it's Boolean, integers, floats, and strings. Null is what we call the unit type. It is a type which is inhabited by only one element. So null is the only value which is part of the null type. And then there's this empty type, which is called never, which is available since PHP 8.1, which means no value inhabits this type. And the only time you can use it is as a return type if you either exit the program, if you throw always an exception, or you're in an infinite loop, like in an event loop. And then we'll have this weird special child, glorious void, which is a bit of a misnomer/lie, because any function in PHP will return a value. So if you assign to a variable the result of a function which has type void, you will get null. So void is effectively null, just you can't actually properly subtype it, and it has some weird compiler restrictions. The other restriction is null has the asterisk is prior to PHP 8.2, you could only use null as part of a union type. Since 8.2, you can use it on its own. User-defined type classes are the types that you probably all use and which are the most useful. We also call them class types, and they are all of the interfaces, all of the classes, and since 8.1, enumerations. And within these class types, we have relative class types. So you can either type something to be self, something to be a parent, or something to be static as of 8.0. Now, I'm not sure why you would ever use the parent type declaration, but you can technically do that. just going to be very strange because you need a child and then always return something from a parent, but you do you. We also have this notion of value types, which is a concrete subtype of a type. I know I haven't talked about subtypes, we'll get there. So false, since PHP 8.0, has the same caveat as null. You can only use it as part of a union type prior to 8.2. And we also added true in 8.2. These are the only value types that exist in PHP. You cannot define your own. If you want to do this, use an enumeration. The callable type represents a function, and it's either a string of characters, it's either a pair of an object instance and a method, it's either an object which implements the invoke magic method, or just, if you are on 8.1, just use the new syntax, which is the 3 dots. This is part of the syntax. This is not just, oh, add some parameters. Sterling, like bracket, dot, 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 bracket, will give you a closure which represents the Sterling function. There's also another caveat with callable. You cannot declare a type property to be of type callable due to some scoping issues. If you want to actually store a function in a property, just use the closure type and again use the new syntax of 8.1 to just get a closure. So composite types. This is, like its name implies, a way of combining multiple atomic types. So intersection types allows you to combine multiple class types to be, I want something to be of type A and of type B. Simple union types are available since 8.0, which tells you I want something either of type T or of type U. We technically had kind of union types since 7.1 with the nullable type, which is T or null, but that just makes everything harder because that's life of PHP. And since 8.2, we have DNF types. So DNF types are types which are in disjunctive normal form, which means you have a list of ors, or you have a list of ands in or. Oh, wait, am I doing this? Not at all confusing, even for me. Yeah, so you have a list of ors, and in each ors you can have an and. So it's basically a union type, and within it you have intersection types. The reason why we force you to write it in this form is due to various reasons. A, it makes it simpler to implement. So that's step 1. Step 2 is if you need to start resolving to make it into a canonical form, you get into the halting problem, which is a terrible thing because it means you don't know if your program will ever stop and actually execute. That's why we force it upon you. And any Boolean expression which is not in DNF type, which is not in DNF form, can be written as a DNF form. So why do we actually care about composite types? So in this box of white box, I have 2 screens. I don't know where to look at. I'm going to look here. We have our whole type universe, and within it we will have type C, which is a shorthand for countable. We will have T for traversable. We will have the intersection of both of these types, and then I also add array, because array is somewhat close. So the reason why we call the type an intersection is because it looks like a Venn diagram, and types which are type countable and traversable live in this middle of the space of both of these types if you look at it as a graph. Whereas a union is you're taking 2 different areas from the type universe and make them together. So what this effectively means is that the intersection of types gives us access to all of the APIs that each of these types defines and allows, whereas a union only gives us the common API between all of the types. So if we go back, if I have something which is only of type countable, I can only call count. If I say I have something of type countable or an array, I can still only call count on this function, because I can't use any array functions or anything else. If I have something which is of type countable and traversable, it means I can count my object, but I can also traverse it in a loop. If I only have traversable, I can only traverse it in a loop. So the intersection of both types allows us to do more with the value. Now the reason why I put array is because countable and traversable, it's kind of the same as an array for most operation, which brings us back to why we have DNF types in certain ways, so that you can do, I want something which is of type countable and traversable, or something which is of type array. And then you can do all of the operations as a for loop and count it and do various things like that. Yes. Now, type aliases, this is only something which is actually true since 8.2, where iterable is now a compile time alias for traversable or array. Previously, it was kind of its own pseudo-primitive type. And the reason we changed it is, again, for implementation simplicity, to check all of the variance checks and everything with DNF types. You cannot, at this time, write or define your own type alias in PHP. So this is how, oh yeah, I forgot to mention it. We're going to do some C code, tiny bit of C code. So in PHP, every value, every variable is represented as a zval, and a zval is basically a Zen value and a type info. The value actually contains the value of what it is, if it is an integer, a string, an array, or an object. Everything else is encoded in the type info, and the type info also gives us the information of what is in the value. The reason why Booleans are encoded in the type info as is false and is true is for performance reasons. So we don't need to do a lookup of check the type info, okay, it's a Boolean, check the value, is it true or false? We know it immediately looking at the type info. Zen type is how we represent types within the engine more globally, and are very simple structures. So the first one, so the Zen type takes a type mask, and it has a pointer to some data. Void pointer just means here's a block of memory and have something in it. Effectively, what is in this block of memory is either another Zen type, or a Zen type list, or a string. And the string is only if you have either a union of simple type or primitive types like array, object, string, and one single class. Otherwise, you bump into a Zen type list so that we can contain the list of like unions or a list of intersection of type classes. So the subtyping and Liskov substitution principle. I think most people must have heard vaguely about LSP. The difficulty is that it's more complicated. So subtyping is this notion where you can replace one data type by another, and it is always correct. And we say S is a subtype of T, which we read in 3 different ways, depending on the resources you find online. Either it's just like the arrow with a dot, either it's just this weird square thingamy, or it has like the equal underneath. And yeah, so S is a subtype of T, means that S can be safely used in any context where you would expect T. LSP is a specific notion of subtyping. And it was defined, like, it's called behavioral subtyping, and it was formulated by Barbara Liskov and Janet Wing in 1994. And the succinct formulation in mathematical term is, let phi of x be a property provable about object x of type T, then phi of y should be true for all object y of type S when S is a subtype of T. This is all of math, there's a bunch of jargon. What does it actually mean? So LSP just means, okay, I can replace a type with another such that the interaction before and after are not affected. So the preconditions cannot be strengthened in the subtype. The post-conditions cannot be weakened. The invariance must be preserved in the subtype. These 3 things, the PHP compiler will take care of. This is when the type errors, when you try to extend, or you will get some fatal errors or compile errors. This is what's happening. The one thing you need to take care of, developers, is what is called the history rule. The history rule is this concept that a child or a subtype cannot impact the behavior of the parent type in ways the parent type wouldn't be able to do. So if you have a robot which has a function move, and you then extend it with another class and you added a function run, what you cannot do is directly modify the properties which indicate the position of the robot without going through move, because this is a violation of the history rule. And this, like I said earlier, this is something that a compiler cannot check, and this is something you need to check as a developer. A way of visualizing LSP is just as looking as your method calls as a pipe, and every argument you pass in needs to go out, and being able to change one by the other just means, okay, I accept more stuff in, and I give something more specific. That is fine, because I don't break any contracts. However, if you try to like take something more specific and give something wider, then you're just breaking the contracts from the users of your API before and afterwards. So what is basically, so the effect on LSP on signatures is that method cannot add mandatory parameters. The parameter types of methods must be contravariant, i.e. a super type. What? Yes, I was lost in myself in my slides. And the return type must be covariant, so it must be a subtype of the parent return type. And property type must be co and contravariant. The reason why we phrase it that way and not as invariant is that, in essence, if you say that I have a class A, and I have which has a property which takes itself, and I extend it and I give A intersection B, being it a child class, it basically resolves to the same thing. Therefore, we do this double check of like, we check it's covariant and if it's contravariant, and not just say, oh, is it exactly the same? This is just tiny caveat on this thing. So covariance of types. In general, S is a subtype of T if S interacts with intersects with a new type U, or if you remove a type from a union of types. So this is basically how it looks like. Okay, super is a bunch of union types. I remove some, I get a subtype. I have some intersections, I add more, I have another subtype. But these are the case in general, because you can have slightly more complicated subtyping relationships. So we have a bunch of interfaces. We say X implements A and B, and we say Y implements also A and B, and we have a class which returns something of type A. This means we can X or Y is more specific than the whole type universe of A, because I'm having concrete implementation of A and Y, which, although they are not the same, they live within the same bubble within the type universe. So this makes it a valid subtype. In the same way, I can say, oh, I want something which implements A and B. This doesn't mean I can't return a union, because, okay, I have A here, I have B here, I have like an intersection here, but both my X and my Y live within the intersection. Although they are concrete implementations and they are different, they live within the same space, therefore they are a subtype. Yeah, more example, A and B or D. We get back into the previous case of I can take either X or Y, because this satisfies the constraint of I am either A or I'm either B, or I'm A and B, or I can just have D. More examples, the reverse is also true. I can have a union type as my parent type, and I can have an intersection type as my subtype. This is, I feel, probably easier to grasp because, well, okay, X extends A. Well, okay, so X is obviously a subtype of A, so this is valid, and I just added a constraint that I want something which also is part of C. So how do you phrase this mathematically? So there's a couple of symbols. So the inverted A means for all. The inverted E thing means there exists. And we're going to work with two type lists, so U and V. So for the type list U1 up to UN to be a subtype of the union type V1 to VM, we need that for every single UI, there exists at least one VJ and one UI to satisfy a relationship of subtyping. So out of all of the union types, like on the parent type, we only need one where one U1 up to UN is a subtype. The other case where we have U1 up to UN being an intersection, being a subtype of the list of types V1 up to VM, we need that for every single VJ, there exists at least one UI such that UI is a subtype of VJ. What this basically means is that if I have a list of intersections I can add intersections. This is basically what it means. So the there exist and the for all, we call these things quantifiers in mathematics. And if you look on the right-hand side, previously I had, which if I go back 2 slides, we had the U before the V. Whereas here we have the V before the U. This simple change means that the order of the quantifier is being changed. We need to iterate over the types of V first, then over the types of U, which completely flips the previous logic. Which looks a bit like this in PHP-ification of the C code. So the first thing is we need to check what are we working with as an intersection type or not, as a super type that we're trying to check, because otherwise then the status code, what we are trying to check for, changes, which makes everything 10 times more complicated and harder on everybody's brain, including myself, and I wrote this about 2 years ago. So, you know. So what lies in the future of PHP's type system? So these are just ideas which may or may not be put in place, but one could be function types, which would allow to define the closure you want, or a more specific closure instead of just callable. So in this case, I'm taking, I want a function, which takes as a first argument an integer, then a string, and it returns a Boolean. Generic types, I don't know who is, considering everybody talks about static analysis apparently nowadays. I don't know who has used generics vaguely. More people than I would have expected, okay. So generics are another way of what we call template types, which means in this case, I can just have a generic collection, which takes, I have a collection of some items of whatever, and I can just add types of this, and I will know I will have elements of this type, which currently you would need to manually implement each collection. If I want a collection of dogs, then I need to create a collection of dogs, and if I want a collection of cats, then I need to create a collection of cats. I can't just use the generic collection stuff and only pass dogs to one, or only pass cats to the other. Something else would be user-defined type aliases, which would be somewhat useful for DNF types, or the typical example would be numeric if I want to accept something which is either an integer or a float. These are just 2 syntaxes I came up on the spot about 6 months ago. In-out parameters is another way on improving upon the very weird and crappy behavior of references in PHP. So currently a reference, if you say that V is a reference, and even if it takes an array as an input, it would only check the value of the type doing function entry, meaning I can change the type of V to an integer and I wouldn't get a type error. The advantage of in-out is it will tell you, it's like, okay, I get something of type array, and on function exit I also have something of type array, instead of changing to whatever I just want to. Okay, this is the fun part for me, because this is my therapy session, where I will talk about all of the weird ways I've discovered PHP does like a bunch of type juggling. So yeah, this is probably how I will look like at one point. Small audience question, just raise your hands, I'm not asking you to shout. Who has heard about strict types? Yeah, most people. Who knows what strict types does? More wavy hands and less hands in general, okay. So, we have 10 type juggling contexts in PHP, and I will try to go through them somewhat quickly. I don't know how much time I have. Yeah, we'll try to go through them somewhat quickly. So the string type juggling context is any time what you're using is a string, so either using echo, print, string concatenation, or string interpolation. So yeah, like true gets converted to 1. You can print an array because apparently that's totally logical, and you just get the word array with a capital A. You can't do this with objects which do not implement the string cast. So that's nice. We actually get a type error. That's cool. Now the next one is integral and string context. This is only used with bitwise operators. I don't know how many of you use bitwise operators. Well, probably if you use anything with flags in a PHP function, you do without knowing. But if both of the arguments are strings, then it will do the bitwise operation on a byte by byte aspect and character by character, and will return you the operation and give you this. Same if you have a string, like a numeric string in both cases, that's somewhat sensible. Now, if one of the cases is an integer or numeric, or not everything is a string, it will try to convert everything to an integer. So 36 union like 123, so the 123 gets converted to the integer, and you get 127. 1e3 is exponential notation, so you get 100, so you get 33 or 100, and which is 1004 apparently. This also works with true. This also works with null. GMP is an object from an internal extension, which is about arbitrary precision. So you can have integers which are larger than 64-bit integer, and so it implements some operator overloading, and so it will call that. But then there's this weird other object that I discovered, which is in part of the tidy library, which is meant to parse HTML and like clean it up and something like that. And for some weird reason, it implements an integer cast. So PHP will then cast the thing to 0, and then do the union of it, and just be completely fine, which is weird, but whatever. Where if you actually try to just pass it a string and then with another integer, then you'd actually get something sensible, which is a type error. But yeah, not all the time. We have somewhat similar with like the numeric type, which is just addition, multiplication, division, and all of these things. Where if both strings are numeric, it will convert it to an integer or to a float, because of 1-3e being a float, and it will then just happily do the addition. Same thing with GMP, overloads the plus operator. Tidy just casts it to an integer, adds it. Now, one which seems sensible and should never fail is the logical type juggling context, which is when you use conditional statements, the ternary operator, or any logical operator, which basically means I'm casting the value to a Boolean, which obviously always is valid, except because GMP doesn't implement a Boolean cast, so PHP is just like, I don't know what you're asking me to do, and I bail out, which is great. Turns out this irrecoverable fatal error, this was something that was prior to exceptions being used in the engine using PHP 5. I don't know if anybody of you remember this, or you're just happy that with exceptions. But this is the only case where this still happens. So that's always great. Oh yeah, that was my reaction the first time I discovered this. It was just like, yeah, what? So comparisons. Oh, we all love comparisons. So first thing, PHP has two different operators. You can either use the normal one that probably everybody uses, which is the exclamation mark and then an equal, or you can use the official SQL syntax, which is with the double brackets. You've learned something today, at least. So this table is the table which exists on the php.net documentation, which explains how types get compared. So if you try to compare two strings together, when one string is null and the other one is, well, yeah, it will convert null to an empty string, and then it will do like a numerical or a lexical comparison. Yes, I said numerical. This will come handy in a minute. If you try to compare something with bool or null to like whatever, it will cast both sides to bool, and then false is less than true. That makes somewhat sense. Let's be somewhat reasonable. So two objects, so built-in classes, so which are defined by extensions, can define their own comparisons. You might have used this with datetime, if I'm correct. Datetime, you can compare two datetime objects, and it will tell you if one was prior to the other one. Otherwise, the same classes compare the properties, and otherwise they are considered incomparable. String resources, int and floats. We'll translate the strings and resources to numbers and then compare this as math, which looks sensible until it doesn't. Arrays, the array with less members is smaller than the other, but that only works if the second array has all of the keys in the first one. Otherwise, this is considered incomparable, and it compares the keys by value. Object whatever, to compare to whatever, object is always greater. Array compared to whatever is array is always greater. Which implies kind of this. So an empty array gets converted to a Boolean if you try to compare it with bool, and obviously false, because empty array is false, is less than true. The second one is the one which I hate, with the third one as well. It compares, because both strings are numeric strings, it's just like, okay, let's just cast them both to integers and compare them as integers, because that's sensible. Same with exponential notation, it's just like, oh yeah, 0e5, this is just 0 to the power 10 times 10 to the power 5, which is obviously the same as 0e9, which is 0 times 10 to the power 9, therefore this is equal. Now, the other ones is just how PHP basically encapsulates that two operands are incomparable, is that if you flip the order, then you get the same result. So if you try to compare a bunch of numbers to a bunch of strings, makes no sense. So left-hand side is always greater. Same if you flip it around, and it's the same with objects, except when it isn't. Because for sure that makes sense, because you can also GMP, depending on which object is the first, it will try to call the first object comparison handler, and the standard class just is like, no, comparing to anything else makes no sense. GMP is just like, let me first try to instantiate this as same thing with float to a certain degree with GMP, except it doesn't work if it's a string for some reason. GMP is a weird object and it's a weird extension. Okay, function type juggling context. So this is the context when a value is passed to a type parameter, property, or is returned from a function which declares a return type. In this context, the value must be the value of the type, except if you have int and you pass an integer to a float, then int gets promoted to float. If the types you are passing are scalar values and the type declared is also a scalar value, then the value gets converted to the appropriate type if it's compatible. And the string type accepts objects that are castable to string. Small caveat to this is that internal functions prior to 8.1 also casted null for scalar types. This now emits a deprecation notice. From my understanding, you all know this because this is like the biggest pain point. So yeah, so interfloat promotion, very basic, just pass something with float, pass it an integer, gets converted, whatever, that's fine. If one tries to call scalar types, usually we'll just try to target the first one if you only have one, but if there are multiple, it will go in this order. First it will try to cast it to an integer, then to a float, then to a string, and at last resort it will cast it to a Boolean. Now this has this weird implication because I decided, and we accepted, to deprecate the implicit coercions from floats to integers, meaning that currently you get a deprecation notice, but you still get an integer. But the moment we actually remove this behavior, you would get a string, which is obviously, I don't know what to do here. Just be aware of this, basically. Now, if the value is a string, and you're trying to pass it to an integer or a float, instead of casting it to an integer and then to a float, what it will do, it will use the numeric string semantics and decide on this if it should pass it as a float or an integer. So if you try to pass 15.6, it will give you a float. If you try to pass a string 25, it will give you an integer. So yeah, so stringable, string castable objects. So the previous thing with the string thing, it doesn't, if you try to pass a string object to this declaration, it will not do the cast because it's not a scalar. This only works with actual strings and not stringable objects. But yeah, if you pass string and you have the toString method, then it just casts the object to string and then it passes. It's somewhat well known. Now, The thing is, I'm talking about string objects or string castable and not stringable because GMP, our lovely child, is able to get casted to a string, but just does not implement either the stringable interface nor has the method toString, but it still works. So this is always great. Brilliant assumptions, PHP. The increment and decrement operator is the next one for the reasons because it's surprisingly weird. So basically, just add 1, remove 1, if you have like an integer or if you have a float. Brilliant. You can also increment strings. It's great. Mark will tell you all about it. I don't know if he's here, but whatever. So this is somewhat strange if you don't know about it. Now, logically, you can't increment an array and you can't increment a resource. Brilliant, that makes sense. However, you can try and increment booleans, but they don't change their values and they don't even emit a warning. It's just like, here, nothing happens. This also works with, except if your string is an integer, then it will convert the integer to the string to an integer, and then it will do normal arithmetic. Again, GMP, because it overloads the operators, works. However, tidy, because it only has an integer cast, now returns a type error compared to normal addition, which is sensible. Oh yes, no. Does anybody know what it happens? Okay, no, I will just talk then. So if you try to decrement null, you just get null, logic, nothing happens, like booleans, except when you increment it. Then you get the string 1. Oh no, then you just get 1. Brilliant, that's great. Now if you try to decrement stuff, however, so you can't decrement a string, except if it's empty. Because then somehow it converts the empty string to 0 and it gives you -1. But if you try to increment the empty string, you get the string 1 instead of the integer. Brilliantly consistent. So the string increment is called the Perl string increment because we took this feature from Perl initially. And it only works with ASCII strings. But it also has these, so it will increment Z and you will get AA, so it will do like this Excel column thing. But if you have trailing white spaces, it does nothing. If you have a leading white space, it loses the carry, which is brilliant. Now, okay, these were weird shenanigans, whatever. Okay, we have like this string and we just iterate it over 100 times, and obviously we're going to get a string, which we don't, because like what happens, this is my reaction, I forgot my slides. At one point, we get to the sequence 5D9, which we then increment becomes 5E0, which then gets interpreted as a scientific notation, which is equal to 5, and then it increments this, and we get back to numbers. Great, this is brilliant. Thank you, PHP. Okay, array offsets. I might skip somewhat quickly through this because it's probably the most boring bit, but array offsets are not exactly the same as what other stuff is. You can pass in an integer or like some numbers, but they behave slightly different. So, oh yeah, and yeah, like an empty key is also a valid key, by the way. That's great. You don't know what it is, but this is fine. Yeah, so null, false, and true, like it will just do this normal comparisons, like normally null gets converted to 0, except here it gets converted to an empty string, because why make it more difficult for me? Floating point numbers do something kind of weird. So at the moment, if it's an actual float, it gets converted to an integer with a deprecation notice, but if it's just a string, you just get the key as a string. That's at least that one's somewhat reasonable, I find, compared to this conversion, but whatever. You can also use resources as array offsets, which is not very consistent, but whatever. Now, we're back to somewhat saying arrays, you can't use an array as an offset, and you can't use an object as an offset, even if it implements stringable. That's at least great. That makes me happy. And the same is like if you unset like the offsets, you get the same errors, and it's just consistent. So whatever, if you unset or or if you try to check a set, or if the offset is empty, everything's consistent, everything's nice. It's a bit weird, but at least it's consistent between all of the operators. And also this, I forgot the way of it, the null coalescing operator. So everything's consistent. It might be weird, but it makes sense. But you can also access string offsets, where, so I just have an alphabet, and I can access the 6th element, which gives me my initial. I can do null, or which gets converted to 0, but PHP complains, which is surprising, that it's just like, oh no, you can't do this. This doesn't make any sense. Like I was happy initially. I was just like, oh great. Like whatever I pass, it's just like a string cast occurred, and it's just like it's complaining all the time. Except if you pass in a string integer, then it's just fine. Let me convert the string to an integer and just use this. You were so close to being good, PHP, so close. But then it types I was on a floating point, which, you know, at least that's nice. And it's same, it's like you can't use an array offset, and you can't use a resource, no objects. It just complains. Now, if you try to unset, it's really like, what are you doing? This makes no sense. Unsetting is like a string offset makes no sense. But depending on how you access this, you get different error messages, because that's just context. And if you're trying to isset, you get clearly no warning compared to earlier, where it's just like, sure, no, yeah, exists, it's fine. You even get like the deprecation notice instead of a type error. So this is just kind of fine, it just works stuff. Somewhat consistent with the null coalescent operator until it isn't, where it decides to throw type errors, which is cool, but it didn't in some other instances, which frustrates me because nothing is consistent in this language. But whatever. Finally, we're getting to the end. So exit either accepts an integer or a string. So if you pass it as an integer, you get a status code. And if you pass in a string, it will just exit. It will just print this line on the terminal or whatever, like the thing. But if the value is not an integer, it will convert whatever to a string, which was very frustrating because I was not understanding why I was having a bug with my CLI script, because I was just like, oh, are there errors or not? Just use it as a Boolean, just pass it to exit, because obviously if a Boolean gets converted to an integer, except here it gets converted to a string. Took me a while to debug. Great. But yeah, so you can pass it an array as well if you want, or a resource. But if it can't get converted to a string, it will throw an exception. So you can basically prevent an exit and catch it and not exit the script, which is funny. So yeah. So these are all of the 10 contexts. Strict types only affects the function type juggling context. Everything else is not affected by this, and even then there are some caveats. So what does strict types do? Strict types is only enabled in PHP scripts which use declare strict types 1. It disables coercions of scalar types in the following cases only: arguments passed to function calls in userland, return values for user-defined functions, and value assignments to type properties. That it is. It doesn't do anything else. So it doesn't change the behavior of my binary operations. That still gets casted however it wants. Neither comparison operators, neither exit. But more importantly, it does not change the behavior of functions which are called by the engine. The engine always works in weak typing mode. So if you call like array filter with an array of whatever stuff, and you pass in a callable which takes an integer, now if you would re-implement array filter in userland, you would get some type errors. But PHP, because of the type conversions it will do them, it will not complain. It will just gladly take them, and you will get an array with information you wouldn't expect. So here's the hot take. Strict types was somewhat of a mistake, because you have no idea of what actually is going through, and just expecting strict types to make the language stricter when it doesn't, and you effectively need to know both typing modes when probably what we should have been doing for the last 5 to 10 years is making the current, like the normal typing juggling, less weird and more consistent, then adding this weird bandage to that. So yeah, thank you. This is all my fault. I have the feedback. The slides are already online for once I uploaded them in advance, so you can look at them if you want to go back to some of the math equations. But yeah, I don't know if we have time for questions. But
we have time for one question. Anyone? There you go.
okay.
Do you think we'll ever see generics in PHP?
Hot topic. I think it's difficult to know. I mean, I think a lot of people want it, and some people within the core team are working on generics. Now, when are generics going to be in the language? Who knows? Could be 2 years, could be 4 years, could be never, could be tomorrow. We don't really know. It's a hard feature to implement, basically. But yeah.